population, it triples every 6 months. And so how long in months does it take to double? So because we're dealing with population, growing and stuff, this is probably a growth problem, a population growth problem. So I'm going to go ahead and set up a population growth equation. This is the way I like to do it. You'll see this, instead of saying a sub 1, you'll see p naught, which is p with the little baby 0 right here. It doesn't matter. This is the starting population, and this is where you're at after growth or decay happens. This right here, the e to the kt, is the growth or decay. Since we're growing, the k is going to be positive. All right, so let's go off of what it says. It says every 6 months it triples, and so I'm going to take this a sub 1 and I'm going to triple it. Whatever happens over here with the e to the kt is tripling the a sub 1, which is the beginning, the initial population, into that. And so now what I want to do is I want to solve for k, because that's the rate and that's what I don't know. And if I want to see how long it takes it to double, I need to know the rate. So let's plug in other stuff that we know. After we get rid of this a sub 1 right here. This was too obvious, so I just got to get rid of it. So since a sub 1 is multiplying the e, I can divide both sides by a sub 1, and we just get 3 times e to the kt. Some people who are really familiar with exponential growth problems, they'll go right to this because they see that it triples. They don't need to have the populations represented. They just need to have a 1 and a 3 right here to show that it's tripling. So for the t, we're going to put 6. Because we know that every 6 months it triples. Now we just need to find k. So I'm going to take the natural log of both sides so I can get rid of the e. I got to get the k and the t out of the exponent. So I'm going to natural log both sides, and that's what gets rid of this base e. And so I have natural log of 3 equals 6k. See, no more e. Natural log of e is 1. And so they cancel each other out. And one of the laws of exponentials is you can take, or one of the laws of logarithms is you can take powers inside of logs, because that power is currently inside that log, and you can drop them out in front. And when you drop them out in front, then you have the natural log of e. It just goes away. It's like going 6k times 1. Okay, so now we get k equals natural log of 3 over 6. Now that is our rate. He's not really pretty looking, but that's our rate. So let's write our equation now with our rate. Oh, look how pretty it is. Not really. That's an ugly rate. Now, remember last time we tripled the a sub 1. This time I want to write it as doubled. So I'm going to write 2a sub 1 times a sub 1 times e. No, 2a sub 1 equals a sub 1 times e raised to the natural log of 3 times t. And that is all what we want, because it says how long in months. That t right there, once we know what that t is, we find our answer. So let's get rid of these a sub 1s by dividing them both sides by a sub 1, which we're allowed to do, says algebra. And then to get rid of that base e, we're going to natural log both sides. We drop the exponent, and natural log of e is 1, so we get natural log of 3 divided by 6 times t. And then to get rid of these guys, to make t alone, I'm going to multiply both sides by 6 and then divide by natural log of 3, or I can do that all in one swoop by multiplying by the reciprocal of that. And so this is what t equals. Do we see our answer over here? 6 natural log of 2 divided by natural log of 3. Yep, there he is. C is our answer. On the 18, a population is growing at a continuous rate of 3% per year. Which of the following equations represents this information? It looks like we got some differential equations in here, which is the whole reason why we're working on exponential functions right now, because there's something special about differential equations that come from exponential functions. Here, check this out. We have a sub 1 times e, times e raised to the 0.03t, because 0.03 is the 3%. That's the rate that we're increasing by. A sub 1 is what you're starting with, and then that's going to equal our population. Now, I looked up here really quick to see if one of these matches what I have right here, and none of them do. They have this weird p with a baby 0 right there. That's pronounced p naught. P naught is the initial population. So I'm going to get rid of this a sub 1 and write p naught instead. Whoa, there we go. We know that it's not the first answer because it says 1.0 0.03, which is not true. It's just supposed to be 0.03. But then when I get rid of the second option, our only option is our differential equation. So I'm going to take this guy and take the derivative of him with respect to t. Let's see what we get. The derivative of p with respect to t is going to be 1 times p prime, which I'm going to write as dp over dt. On the other side, the p naught is a scalar. That's just something multiplying to the e, which has the variable. And if I take the derivative of e, I just get the same thing. But when we have something inside the exponent, we have to then use the chain rule and multiply it by what's inside derivative, or prime. Okay, so I got to take the derivative of this, which is just going to be 0.03. So I have 0.03 p naught e to the 0.03 t equaling dp over dt. And if I look at my answers, I don't see it yet. The answer is not there. There's some answers that are kind of close to it, but they're not exactly it. See, I see this p naught e to the 0.03 t. Oh man, I wish it was that one, but it's not. There's a 0.03 multiplying to it. So what is this junk over here? Where does capital P come from? I'll tell you where that capital P comes from. It comes from this. You see what P equals? P equals P naught e to the 0.03 t. P naught e to the 0.03 t. And this is a strictly like differential equation type happening right here. I'm going to take this dude out, and I'm going to put in P for that dude, because that's what he equals. And then I get 0.03 in front of it. dp over dt equals 0.03 times P. And then we see that our answer is D.